Help me out. What page is this, Emma? 31. So there's I think it's just a one question. Oh no, two question mark. Okay. So take a look at this on page 31, and see it individually or maybe as a group. You can answer question one and maybe question two. So you guys can do this. That was a good catch. So question one, question two. All right, Nick. Just because I'll practice your name, you know who you are. Did you say D?
No, we said C.
Okay. I'm glad you didn't say D. I want to talk about D for a second. But you gave me more than I wanted, but that's okay. I like that. Yeah, it's not D, and I'm trying to think okay, maybe what was the question writer thinking, right? Like, why would you think D could be the right answer? So what can you kind of maybe think? Well, what would the problem have been if D would have been the answer? Could you think how is it could you modify that function, Easton?
It would just be 3x plus 1.
Yeah, maybe if that wasn't a quantity squared, then that derivative would have been 3. Perfect. Okay, cool. And then we know that we have this power that we can bring down, right? And so perhaps maybe that's why B is an attractive answer, but also still wrong. Because, we bring the 2 down, right? 2 times 3 is 6x plus 2. But that's not right. And you said C, which is correct, but where is 18x even coming from? How did you know that that's the right answer?
You just square the 3x plus 1.
Okay, so you're doing algebra first. Yeah, and that's a really good point. Whether you do algebra first and then calculus, or calculus first then algebra, they both should give you the same result. So if you algebra it first, right? So and Nick said, squaring that out. So really f of x is equal to 9x squared plus 6x plus 1. Now I can do the power rule. Oh yeah, the derivative of 9x squared is 18x. The derivative of 6x is just 6, and then the 1 is a constant. So perfect. Yeah, and I'm hoping that you were able to maybe have that conversation, or just know that I just square it out first, then take the derivative. Okay, and so I will come back to that, I believe. But also, how about question 2? Right, it says, what happens to the graph of sine x when you put a coefficient in front of the x, right? Like sine of 4x. How is sine of 4x different than sine of x? Yeah, Abram.
Has a greater amplitude?
Has a greater amplitude? No. Because the amplitude would have been if the 4 was here. Has a greater something, but not amplitude. What do you think, Aro? It's a greater frequency. It has a smaller period or wavelength, right? If we're going to use some physics, terminology. It's a greater frequency. It changes more often. So if the normal the normal sine function looked like this, sine of 4x would have to change 4 times as fast. You'd have to get 4 of those little intervals, 4 of those sine waves in a normal one, right? So 1, 2, 3, 4. So I'm going 4 times as fast, but the amplitude should be the same. But if my derivative represents the slope and my function's changing 4 times as fast, then the derivative also has to somehow be representing that 4 times as fast, that frequency. And so, and there's the thing is that I can't algebra that, right? I could algebra like 3x plus 1 squared. I can do the algebra than the calculus. I can't do the algebra than the calculus here. I mean, I guess I could use a double angle formula twice and then get some product rules. Oh, do I want to go down that route? I don't. I kind of do. Never. Okay, just humor me then. Two sine of 2x. So that's the, like sine of 4x is, oh no, sorry. Sine of 2x cosine of 2x. That's the double angle. But then I'd have to expand those as well. So 2 times 2 sine x cosine x. And then I'd have to take that times the cosine of 2x. Oh, that's not going to be good because I'm going to have cosine squared of x minus sine squared of x. And I'm still going to, well, then I could know that as cosine and yeah, wow. So you could do it. And it involves a lot of products and patience. Or there's a better way. Because what's happening is that there's a function that's inside a function, right? There's a composition here, sine of 4x, 3x plus 1 squared. So there's a more efficient way to find derivatives rather than algebraifying them or trying to remember all of your trig identities. And it's called the chain rule. Okay, so the chain rule allows you to take the derivative of something that's grouped within another function. And so the derivative of f of g of x, and I'm going to rewrite this just because I want to say the derivative of f of g of x. I kind of want to give some magnitude to my parentheses just to show like which function is embedded. So it's f of g of x. It's not multiplication. It's not f of x times g of x. It's f of g of x. So if I want to find the derivative of f of g of x, I do the derivative of the outer function, and I can't change that identity. But then I'm going to augment it, multiply it by the derivative of the inner function. And that right there sort of represents the chain. In other words, you're attaching another derivative through multiplication. And the more embedded functions you have, you just continue to multiply by another derivative until you get to the inner core. You know, like kind of thinking like of layers of an onion or whatever. So looking for grouping symbols. So some grouping symbols, you know, parentheses, that's an obvious grouping symbol. Looking for square roots because you group things that are within the square root, right? Look for trig, since we know the derivatives of trig, right? Derivative of sine is cosine, derivative of cosine is negative sine. You know, and then tangent is secant squared, and cotangent is negative cosecant squared. So look for those. Eventually, you know, we're going to get exponential functions, logarithmic functions, those transcendental functions, bless you, inverse trig functions, but like those are, we don't know them yet. So they're coming, but look for grouping symbols. Okay, so going back then to Nick. Yes, Nick? Yeah. Going back to Nick's correct answer of 18x plus 6, let's see how we could have gotten that using the chain rule. So according to the chain rule, the derivative could have been written as, well, the outer function is the 2, so the 2 would have come down, and you would just leave the inner function alone. You can't change the identity of the inner function. It's still 3x plus 1. You're not changing its identity. But then you would immediately multiply by, okay, inside that function, what's the derivative of 3x plus 1? 3. So I have 2 times 3, I've got 6 times the quantity 3x plus 1 to the first power. Oh yeah, that clearly is 18x plus 6. So I can get there. And kind of coming back to sine of 4x, just to kind of complete that, if my function is truly sine of 4x, then the derivative, so let's do that. So let's think about dy dx. So kind of just ignore 4x. I don't really care. The derivative of sine of anything is cosine. Now, so I'll call that 4x. And then what's the derivative of the inner function? 4x is 4. So we put this 4 in front, and so that sort of is going to tell me, oh yeah, the derivative is going to change 4 times as fast of the function cosine 4x. Do you remember the Power Roll song? If you heard closely, it talked about like elephant shoes, or no? If not, it does. But I love it because like there was one year I was teaching, and I'm like, I don't care if it I don't care like sine of what? Sine of x, sine of 3x, sine of elephant. It doesn't matter. The sine of elephant is cosine of elephant. And then you worry about how do you do the derivative of an elephant. And that kind of became a running joke that year. But then all of a sudden I heard that song from Calculus Musical, and they throw in this elephant shoes. I'm not sure why, but I'm like, oh my gosh. Anyway, up here in my head, it makes 100% sense. So anyway, don't do the derivatives too quickly, one at a time. So let's practice. So so y equals sine of x squared. Again, it doesn't matter. Sine of what? Just cover it up. Derivative of sine is cosine. You cannot change what's inside the angle, or sorry, inside the function. So dy dx is equal to cosine of x squared. And then do the derivative of x squared, which is 2x. Okay? And it's only, it's just a one and done thing. When you first learn chain rule, some students want to do it again and say, oh, do it too. No, there's only one function within sine. It's the x squared function. Nothing's inside the x squared. Now, I would probably just put the 2x in front. So 2x cosine of x squared. So try number 2, 3, and 4, and 5, and 6. And I'll do them too. I just won't talk through it. I'll just write them, and then you kind of check to see, or check in your group. And you don't have to do a ton of simplifying, but you could do some simplifying. So, and please check my work, because I was having brain parts last period doing simple math. So does that make sense? Does that look okay to you? Did I make any mistakes?
Number 2, sine negative sine. Yeah.
I knew I was going to make a mistake. Thank you. Because the derivative of cosine is negative sine. Excellent. Thank you so much. Like I said, I think my brain is still on. Good catch on that. Whoever caught that. How about the other two? Does 3 and 4 look okay? Okay, good. Okay. So let's go 5, 5, and 6. I'll leave the last two up there just so we see them again. And you don't have to rationalize number 5, just, but there is a chain, because square root, there's something within the square root. Oops, I'm sorry, Emma. Did I go too quickly? That part? Okay. Because I was like, wait, just to make sure. Ooh, product rule. Let's go off to obey product rule. Okay. Hopefully I didn't make any mistakes there either, but who knows. So back to the square root function. I just in the habit of knowing the derivative of the square root is 1 over 2 of those roots, right? So 1/2 power. So I just automatically transition down to this chain rule, put it on the top. Now for 6, I have a product of 2 functions, and within that product, there are chain rules. So I can only do one derivative at a time. So again, like thinking about, okay, the derivative of sine of 3 theta is 3 cosine of 3 theta, but then I have to leave cosine of 6 theta alone. And since I didn't do its derivative, I don't multiply by 6. And then now I leave sine of 3 theta alone, and I do the derivative of cosine of 6 theta, which is -6 sine of 6 theta, or negative sine 6 theta, -6. So you still have to obey the structure of product rule. You still have to obey the structure of quotient rule. But then when you start doing those derivatives, you might have chain rules within that. Okay. And then I love the next one. It's like a little puzzle here, right? So I'm not going to tell you what f or g is. I'm just giving you some specific derivative values. Okay, so can you find the derivative of this composition at 0? So do chain rule. So if I want to find h prime of x, that means I do g prime of f of x, and then multiply by f prime of x. So don't do the derivative too soon. Leave the f function alone. And then just use the table. Right? So g prime of f of x, well, according to f of 0 is 2. F prime of 0 is -1. And then g prime of 2 is 6. So I believe the answer should be -6. How did I do, Nick? Did I do okay?
Yeah, I screwed up. Someone said screw check.
Uh-oh. Louisa was shaking her head. Yes, I did this okay? Did anyone else agree? -6? Okay. All right. Try number 8. I'll see if I can help make out this too.
Yeah.
F prime of 0. Right, so f of x, f of 0 is 2. So then now you do g prime of 2. Yeah, I think you're trying to do multiplication. Make sense?
Yeah.
Got it. Okay, now try to rate. And obviously 9. We'll just do them all. G of 2 is 1, and its derivative is 6. And then f prime of 1 is 2. Did anyone get 12 for B? Yes, okay, cool. Or not B, I'm sorry. The second one we did was 8. I like that. That's 8. All right, then we'll have one more, number 9. So Q prime of X equals times 2x. Oh, sorry, 4x. So then we put in -1, so f prime of -1 squared is 1, which is 2. And then times h is a normal -4, not inside the function. Do we know f prime of 2? Let's see, f prime of 2 is 3. Huh. So 3 times -4, -12? Alright. Alright, I'll come full circle, Nick. Did you get -12?
Yeah.
Yes. Okay. Alright. Are there any questions there? Yeah, Emma.
How'd you get from the 4x to the -1?
How did I get
Oh, wait, no,
Oh,
sorry. I
because
figured
I'm
it
just
out.
subbing in
Yeah.
-1, yeah. And so that
Yeah.
that function was just a function all by itself.
I just skipped subbing.
No worries. Okay. Anything else? So then I think there's 2 more examples, right? Yeah, awesome. So these I pulled from some multiple choice questions. I just pulled off the multiple choice answers. So see what you can do with these 2. Find, I don't know if I gave you directions for number 10. Find the derivative. Okay, so find f prime of this. And there's definitely some method to my madness, and madness to my method as always. It's good that we see these kinds of questions. For which one? You could use product rule. You could also use a chain rule. So really chapter 2, which we're in, is we're just kind of get a lot of derivative rules. Then when we get out of chapter 2, we'll apply those rules to some things like physics, applications. We'll do some geometry in later chapters. So exciting. So honors geo, like we could be reunited since we did geo together, right? We're back in. We'll do that at the end of the semester. Start next. You know, it's interesting. Ella had mentioned number 10 using product rule. You don't have to, if you recognize what the outer function is. Because remember, chain rule is all about starting on the outside and working your way in. What's the outer function in number 10? The squares. But it's notationally deceiving. Because, like, when we see sine squared 3 theta, we don't always equate that, oh, that's the sine of 3 theta squared. But that's exactly what it is. That notation means that. So the most outer function, I don't care what it is, whether elephant shoes or not, how do you take the derivative of a square? It's 2 times that thing to the first power. So my derivative, if I'm going to use the chain rule, it's 2 times that thing to the first power. Oh, I think sometimes I would put like a big dot there. Like if I chose like a highlight color, like this dark color. Like, okay. So I don't really care what's here. Its derivative is 2 of those somethings to the first power. And then you're like, oh, what is that something? Oh, sine of 3 theta. So then I need to multiply by its derivative there. So then I'll get rid of my cloud. So I can't change the identity of sine of 3. Oops. I'll get rid of my cloud and my cloud 10. So I still have sine of 3 theta, but then I need the derivative of the sine function. And so my cloud's kind of covering 3 theta. Derivative of sine is cosine of 3 theta. Can't change its identity. And then, now 3 theta is different than just a theta. So what's the derivative of 3 theta? 3. This has 3 chains because there's really 3 functions. There's the square, there's the sine, and then there's what I call, I guess, the triple, right? So we're right. So I have all three things, and I can move the 3 and the 2 in front, and call this 6 sine 3 theta cosine of 3 theta, and then I just got really excited because there's like a half or there's a double angle in there right now, right? Sine of 2 theta is 2 sine theta cosine theta, so I could condense that if I wanted to, right? Like because I've got 2, so I got 3 times. I should write that better. I've got 3 times 2 sine 3 theta cosine 3 theta. So this is this is the expanded double angle, right? So how would I combine that up? What does 2 sine 3 theta cosine 3 theta become? Got a couple of thoughts. It's not cosine because it's not the it's definitely a sine. So someone said sine 6 theta. Let's see. Well, sine of 6 theta would be 2 sine 3 theta cosine 3 theta. So is that right? Is that what we have? Did we have a 2 sine 3 theta cosine 3 theta? So we could condense that into sine of 6 theta. How exciting. But then also you would have had, where'd it go? There it is. Also you would have this extra 3 in front of here, right? So you'd have what? You would have what? 3 times, okay, so you'd have, just 3 sine of 6 theta, that's all. So that's cool. Now, do I expect you to do that on the homework or no? I just have fun. All right, where'd it go? Yeah, there it is. Now, if you would have done product rule, you would have gotten the same thing, right? Okay, and then last thing, sorry, one more. So I love this notation. So it says find the first derivative, find the second derivative, and we don't know what f is, so we just have to express it in terms of f prime. So dy dx is equal to f prime of 6x squared, then chain rule of x. So don't do the derivative of the inner function yet. So take a minute, find the derivative of this. And there's the first derivative. It also asks for a second. And so I want to give you a chance to find that second derivative. I'm going to circulate the room. You just have to leave it in terms of f notation. I was looking at the calendar. I don't think we have any quizzes this week. I think our next one's next Tuesday. Is that right? Tuesday or Monday, I think next week. We're on schedule for Tuesday the 14th. Okay. So a week from today. Remember, that's not a typo. The notation of the 2 is the second derivative of y with respect to x twice. Okay. Does that make sense? make this go with that. Right? Why is this 12x here? Why is there a second 12x? Abram?
Because when you do chain rule for the second time, you still have to do the same thing. We have double prime of 6x squared. So it's just the derivative of 6x squared again.
Oh, well then what's this 12x there for?
That's from product rule.
Yeah, right, good. So one you're absolutely one comes right from the chain of the inside. One is still because I didn't do anything to that 12x. So yeah, perfect. Yeah, perfect. In my head, I had them switched. This is the one I did nothing to, and that was the chain. But guess what? It didn't matter, right? Because multiplication is commutative. So cool. Yeah, very good. Anything else on that? So that's the chain rule. So again, we've got product rule, quotient rule, and now we have the chain. So then that's all I have new. The next sheet is homework, but I also want to pass out your PGAs from Friday. Most of you guys did really well. You saw the scores online. Just see what questions you have. So Ella's group, you could take this apart, see your own copy. Emilio's group, and then whoever's got graded, you're gonna wanna like see so you can check yours. Abram's group. Someone can just hold on to Alex. Okay, so let me pull up the solution. You might have a question or two. Let's see, and then the rest of the time can be for work.